Hi, my name is David de las Casas. I'm a Maxwell render expert at Next Limit Technologies. I'm going to show you a tutorial about how to render in a Converse All-Star shoes with Maxwell Render 4. For this, I've made two 3D models, one in low poly with 3ds Max and another one in high poly with ZBrush. Let's go to start with 3ds Max. When I finished my model, I exported the object with GoZ to ZBrush. This is a tool that you can find in 3ds Max and makes a bridge between this software. When I open my model in ZBrush, I must model in a high poly from the initial object. ZBrush is a software where you can work like if you were playing with clay. It's easy and funny. You can make details like wrinkles and creases on your model, adding subdivision levels to the object. But don't worry if you add a lot of millions of polygons, because you are going to need only the low poly object for rendering. With the model in high poly, you can get texture maps, normal maps, and displacement maps with total precision to render them later on the low poly object with Maxwell Render 4. Okay, now is the moment to export the 3D model for rendering. If you are working with 3ds Max, you can use the plugin and work directly with 3ds Max interface or export the project to Maxwell Studio. If you want, you can export too your object to Studio in OBJ format from 3ds Max or ZBrush, like you prefer. Today, I've exported the OBJ format from ZBrush to Maxwell Studio and I'm going to work from zero all materials for you. The first material that I'm going to create is the shoe fabric. For this I need a diffuse map. A diffuse map is the most common kind of texture map. It defines the color and pattern of the object. UV mapping is the process of projecting a 2D image to a 3D model surface. The letters U and V denote the axes of the 2D texture because X, Y, and Z are used to denote the axes of the 3D object in the model space. When you have finished loading the diffuse map, you can make different previews of your material and check how the light falls on it. Maxwell Render offers you many different options for that. After, you can check how the material will be displayed on the 3D model. Drag your material to the object and place on it. And if you want to see the result on your 3D model, you can look for the option texture inside the display menu. Select it and turn the object in the workspace. Now we are going to look at the normal map. Normal mapping is a technique used for faking the lighting of bumps. It's used to add details without using more polygons. A common use of this technique is to greatly enhance the appearance and details of a low poly model, generating a normal map from a high poly model. Finally, to finish our fabric texture, we will add a little more density or weight to it. For that, we must select a new bidirectional scattering distribution function and reload a diffuse map and a normal map inside its corresponding box. The BSDF contains all the parameters needed to create many different types of materials, for example, glass, plastic, metal, skin, or wax. The most simple materials are created with one single BSDF, while others are a mix of several BSDFs, or even several layers containing several BSDFs. Good. Let's go to launch a render preview to see how is the 3D model with the fabric texture on it. Okay, I think we are on the right way. As you can see, the normal map is doing its jobs with the lighting of bumps. Even the rugosity of fabric is represented. For other parts of fabric texture that we are going to use on the Converse All Star, we must repeat the same process that we have just done. Of this way, we will put the texture on the model little by little. Now is the time to make the plastic texture. The Converse All Star has 3 different types of materials: fabric, plastic and metal. So really, we only need to configure each material once time, and then we will repeat each one of them for the different parts of our 3D model. The process for making the plastic will be similar to the texture fabric, but at this time we will add some brightness in the diffuse map. For me, it's very important to put a new name for all the materials that we are creating, to know at any time what part of our 3D object belongs to each one of them. I would like to explain you some basic concepts about the creation of materials in Maxwell. The reflectance of a material refers to how it reflects the light it receives at the surface. In other words, its surface color and intensity. They are defined by the reflectance 0 degrees, the color at front angles, and the reflectance 90 degrees, the color at glazing angles. A white reflectance means that all the light that falls on the objects is reflected back, and a black reflectance means that all the light is absorbed. The reflectance 0 degrees is the object's main color, and the reflectance 90 degrees is the object's reflection color. Use transmittance and attenuation to control the color and transparency of the material, and use the NG parameters to control the index of reflection of the material. And what about the roughness and bump? Roughness allows you to add tiny imperfections and minuscule details on a surface to make it reflect light in a more diffuse way. The roughness of a surface can range from 0, perfectly smooth surface, to 100, pure diffuse. You can also set a black and white texture to control the roughness. Brighter values in the texture create a higher roughness. The bump mapping allows you to simulate grooves and imperfections on a surface. Normal mapping only simulates these grooves on the surface. It doesn't actually create the geometry in any way. Brighter values in the texture will create bumps on the surface, and darker values will create indents. Alright, we are going to put a camera in our scene, and I will choose a Canon camera sensor, mainly because I like this lens. We are going to check now how the materials show on our 3D model, and for that we are going to launch a preview render. Well, I like the roundness of the fabric and the gloss of the plastic. Now we just need to copy the values of these materials to the rest of materials of our Converse shoe. When we have already made all the materials of our Converse All-Star, we must make the metallic material of the rings. As an alternative to the reflectance and NG values, you can use an IR file which provides Maxwell render, with the exact index of refraction for each wavelength of a material. An IR file may contain dielectric properties even if it's a solid material. For this reason, you must always apply a material that uses an IR file to a model that has a real thickness and is not only a single-sided polygon. Surface properties as roughness and bump can still be changed with using IR files. Naturally, a BSDF with an IR file loaded can still be mixed with other regular BSDFs to create material variations. And finally, here is our metallic texture finishes. From this moment, we will prepare the final stain. We'll need two things for make this: lighting and a background. Let's start with the background. We can find one inside the library menu. We import it into our scene, place our camera with an interesting point of view, and add a white material to our background. Okay, let's go to launch a preview render. I really like it, but I think we could give more emphasis to our textures. For that, we will add a displacement layer to some of them. That sounds like a good idea, doesn't it? At least for me. Before adding the displacement map to some textures, I'm going to configure the lighting set. To do it, I'm going to add planes to the scene, and I'll put an emitter to them to provide light. Emitters in Maxwell Render are part of the material system. An emitter material must be applied to the geometry you want to emit light from. To optimize your scene, try to use low polygon geometry for your emitters. A single polygon plane will do in most cases. This is a simple process, but required testing until you get the illumination you want. Let's go to see how to do it quickly. Alright, now is the time to add displacement layers. With this method, we will enhance the reliefs of our Converse, and we will get more elements. Displacement is a powerful texture-driving tool that can help users to create real geometric details on objects. Contrary to bump or normal maps, the displacement feature simulates real geometry at render time as if it were actually modeled. This feature is very useful for adding fine details to a mess which would otherwise be difficult or impossible to model. But believe me, with ZBrush there is nothing difficult to model. Displacement uses a texture to define the geometric detail. We will add displacement to our model for all textures, except for matter rings. Let's go to see a preview render and check the difference. Now we have in our textures more relief, both in plastic and fabric areas. Everything looks more natural now. Well, we are at the end of the tutorial. Now we just have to place the camera at an angle that we like, set the f-stop and shutter of camera parameters, and launch our render. If you want, several render channels are available, useful for compositing tasks. You can enable the channels you need and choose the file format for each channel. Hope see you soon and enjoy with Maxwell Render.